So, phoneme recognition for fan and profit. Uses of more direct representations of speech. Or, in English orthography. The suffering that Jens goes through. When I showed him that first slide, of course you did. The matter was raised that because I can pronounce an O and an O, that it's not necessarily the case that mine is a monophthong, but I base that on a recording, and for demonstration purposes, that is was originally the output of a phoneme recognition system for English that someone else trained, and I just corrected it a bit to match my Irish pronunciation. But anyone who can read a spectrogram can see that this is very definitely a monophthong, not a diphthong. Okay, so things that I've done. It's the TA duty, thesis supervision, and this paper that we did for the PSST challenge, which actually was a course project for the speech and speaker recognition course. And that directly led to this work that I've been doing most recently on trying to make more use of phoneme recognition, both as a way of bridging the gaps between ASR and an official transcript that isn't quite trustworthy. And also, while we're at it, trying to get acoustically validated pronunciation lexica for text-to-speech purposes. And so TA duty, TA'd on both these courses this year and last year. And I supervised this thesis, which also involved phonemes. The thesis isn't available, but a paper derived from it is, and if you follow that QR code, it'll take you to the archive page. So, first presentation. Ah, damn it. So this paper was presented at the Rapid 4 workshop, which was co-located with LREC last year in Marseille. The aim of the challenge was to get phoneme recognition for aphasic speech and to improve it over an established baseline that the organizers provided. Along the way, the organizers said, oh, oops, turns out we did too good a job. A bunch of people emailed us saying, we can't beat the baseline. So, we did. Happy days. So we focused on data augmentation. So we tried augmenting the original, and we tried matching out-of-domain speech using data augmentation so that it sounded more like the in-domain data. We tried using phonetic language models, we tried using voice conversion, and we tried using synthetic voices. I think this has been mentioned in several 30% seminars, but in passing, but this is the full presentation. So the augmentations we used were Gaussian noise, pitch shift, time stretch, and voice conversion. Basically, we listened to the data and tried to figure out what augmentations will make it sound like that. The choice of Gaussian noise instead of white noise or pink noise or brown noise, Shivam said, do that. And we said, yeah, okay. So we had 2,300 segments from PSST, 1,400 from TIMIT, which, so when we're using TIMIT, we tried to map it down to the same phone set that was used in the Rapid Challenge. TIMIT has a slightly more expressive phone set, and there were things that didn't quite match. So rather than trying fudge it, we just omitted anything that didn't match up, and that drastically reduced the amount of data. The training set by default is about 3 hours. We were left with about 1. But it occurred to us afterwards that we didn't need to keep the test or validation set. We could have used those, and that would have been an extra 2 hours. And we tried to do things with common voice. That was mostly Birger. So we tried using base and large wave-to-vec 2 models, and surprise, surprise, the bigger model performed better. But using the base model was a hell of a lot faster, and you know, there was a moment when Birger asked Jens if he could, oh, can we use the stroke banking machines if Jim does it? And Jens said something to him, but it seemed more like a, convince me type of thing. But I don't know. Someone else came along and said, oh yeah, okay, that's that. And we just dropped it and used things like Kaggle and Google Colab. So I think this person had this false idea that Jens is unwavering in his opinions. He certainly has strong opinions, but no, I've seen many times since then how excited he gets when he gets a new perspective on something. So we used voice conversion, but we had very, very little data per speaker. If we'd had more data, it could have worked out better, but this was particularly noisy data. It was recorded on something like a cassette recorder in a quite reverberant room, and the cassette recorder was on a table between the interviewer and the interviewee. So it really did not work out. We used pitch shift. That worked quite well with augmenting the PSST data. Gaussian noise worked quite well in augmenting mostly the timid data, the clean data that we were adding. Time stretch, we added this because people with aphasia tend to draw out the things they say. And room impulse response, well, from every recording, you could hear the echo. So we used this, and it turned out to be the most successful augmentation individually of the timid data. And so we combined the augmentations in as well. Yeah, this ended up being a little bit of a... So Birger is a very big picture kind of person. I'm a very detail-oriented kind of person. And there are a couple of axes were kind of at opposite ends. So one of the things, the augmenting the PSST data, I thought, well, that doesn't seem like the way to go, but I'll show you how. And it ended up working out quite well, to my surprise. But he wasn't convinced that we need to break it down and show which combinations work. Yeah, when the organizers asked for a table comparing all of these, it was like, isn't it good that I have that? We tried using language models. There was little or no improvement over the baseline using this. And we got these nice looking results. So PER is phoneme error rate, and FER is feature error rate. So for each phoneme, you get this phonetic feature vector. So like if it's a vowel, it could be front, it could be rounded, it could be nasal. If it's a consonant, this will be place of articulation, etc. And so you can get the phoneme wrong, but get most of the features. So like if it gives a d instead of a t, that's one phoneme error, but it's only one feature error. And so it counts a lot less. And so augmenting the data worked out, increasing the size of the model worked out. Oh, wow, I haven't looked at this slide since last year. Yeah, the best performing model combined aphasic and non-aphasic data. So the domain adapted data. We got 21% phoneme error rate, which is acceptable. So anything, if you think of it analogously to word error rate, anything below 30% is worth fixing for a human. Anything above that, just scrap it. You may as well just listen and type it out by hand. And so this was the original former slide. But it was a challenge. We came second. Yay! Of 2 teams. But the other team was Baidu Research. If you're not aware, Baidu Research are the people who created the model that led to the paradigm shift towards end-to-end speech recognition. So they kind of know something about this. Also, they've got a lot more money and they were able to train on massive models. So they were using the, what is it called? VoxPopulus models. I couldn't use those because those are not open source. Meta likes to say open source a lot, but they don't like to do it. They have recently been asked by the open source initiative to not do that. I think maybe trademark and lawyers may have been involved somewhere. But yeah, these are not open source, so I didn't feel like I could use them. So we were stuck with much smaller models. So at least we bet them on 2. It's not nothing. And so yeah, this is the citation for the previous table. And so, oh, wow. I took 10 minutes longer doing that last time. Okay, so this most recent one was given recently in the University of Gothenburg. Apologies to people who've seen this before. So one of the projects, well, we're using Riksdag data for multiple projects. So I mentioned earlier that we're using phoneme recognition to try and bridge the gap between transcripts that are kind of untrustworthy. What we think happens, what happens generally is that they want to represent the intent rather than the literal word for word transcript. So the speeches are filed in advance and then those are lightly edited, but you know, they may or may not match what was actually spoken. So we want to find out things about how people speak. We'd like to have better training materials and we want to develop iterative training processes. So this is part of the Subtitles project, which is a multidisciplinary project. At the other end, we have people who are looking at the psychological aspects of how terror is being discussed in Riksdag. And so we have data for about 10 years. Well, we have data for about 20 years. We have this almost 6,000 hours of process data. And so these are the places, well, the counts for the amount of times that terror or compound words that include the word terror occur. So in 826 transcript files, but over 1,000 files that are the result of ASR output. And 6,700 words in the transcript, 7,200 in the ASR output. So something is going missing somewhere. And we have these counts for, so this is the transcripts. And it's quite similar for the ASR, but slightly larger in most counts. And these ones in italics have a different order. So see it again. So there are mundane issues whenever you use ASR. Mundane issues. Oh, okay, that wasn't loud. So the point here is that the video starts at this point and it's missing that word, but the transcript includes it. So we can't trust things like that. Then there are things like normalization.
Kapitlet, 4:e paragrafen.
This one was fun.
6. Debatt.
So you can see what happened there. She said E6, but this gave EX.
Och utvecklas. Tack fru talman och tack.
So mundane recognition error. So we've mostly solved the normalization issue. This Nemo text processing module includes full support for Swedish, which took way too long, but we're using it for what's called acoustically validated normalization. So now they describe this much more complicated process where they use like a BERT style language model to rate multiple outputs. What we're using is the composition of a basic n-gram model with the potential outputs of the finite state transducer that's created by this. And that creates an acceptor, and it will accept any of the possibilities. So can we trust transcripts? For this, we're using an ASR model that comes from Kobe Lab, the large VoxRex Swedish. So in the transcripts, we get some things that were never actually said. So this is in the transcript, but not, it was never spoken. Doesn't change the meaning so much here, but other places it could. Then, you know, phrases can be moved. This one was up here at the start of the phrase in the transcript, but was moved to the end of the sentence when spoken. Some things are just added in the moment. They just added in these couple of words. And so what can we find automatically? Well, we can find false starts. So when we have on the right side a valid word, and then on the left side a word that ends with that but starts with a substring of that, that's a pretty clear indication that this person had a false start. This is quite easy. Then you get things that are very indicative of alternative pronunciations. So, you know, clearly someone had a different dialect, or they said the word really quickly. And, you know, a WAV2VEX style model is trained with CTC, and it basically predicts every frame. And if something isn't quite audible, then it's omitted. Then we get filled pauses, so like an or a But wait, didn't OpenAI Whisper solve ASR? Well, we can't really trust it, because the data that we're using was probably part of the training data. And we get this thing where the word tak disappears when it comes before Talman, Per Talman, or Fru Talman, because this is never included in the transcript. The transcripts only ever start with one of these three phrases. And so anywhere that this occurs in anything spoken, the word tak disappears. Then you get these strange insertions. So, I mean, this is about 5 minutes, and well, I think in total it was about 5 minutes, but I didn't think I needed to put all that much. But yeah, this was silence. Nobody said these words. But you can see what happened. This is stuff that probably came from YouTube. And, you know, this is one of the things that was mentioned by an anonymous ASR or TTS researcher recently. But yeah, this kind of thing happens all the time because people use subtitles in really strange ways. So our alternative is to use phonemic recognition. I'm using the word phoneme in a very technology-oriented sense, and apologies to anyone who knows phonetics or phonology. And for our data, we're using VoxHome dataset. So VoxHome is an island. It felt more appropriate in Gothenburg to have this slide, and I forgot to check. It's a really nice place. They have a nice Christmas market. Very picturesque. One of the people we were there with said, "Oh, it's like a setting for a Hallmark Christmas movie." And, you know. Then VoxHome with a W was a dialogue system that gave information about shipping, mostly to and from VoxHome, as far as I can tell, but you know, there was more than that. So it incorporated text-to-speech, ASR, face synthesis, and dialogue management. But in the earliest versions, there was no ASR system, so there was a Wizard of Oz setup used. The data from these sessions was transcribed at the word and phoneme level, including non-speech acoustic events. This is a diagram of the system. There was quite a lot happening there. I think just about everything that happened there would be replaced by neural network these days, but a lot of this was rule-based or HMM-based or... Oh. Yeah, I saw this video in Jens's course, and where am I going to find this? I thought, Joachim has to have a YouTube channel. And sure enough, yes, he does. This is what the original data looked like. That was fun. There seems to have been a couple of different conventions, like things seem to have been done at different times. So it's been fun. So there are some frames that are inconsistently labeled. There are empty frames used to mark unrealized segments. I mean, I see why they're there, but they're kind of annoying. A couple of schools of thoughts about the generated phoneme sequences, whether to include the non-speech events or not. And there was a lot of copying and pasting of files, so the metadata is often like really wrong. So here's some videos with output from the phonetic or phonemic-ish. So this by chance was one of the first things I picked out after I think it was 3 weeks of running Whisper across 6,000 hours, and also WAV2Vec 2. This little ha in the middle is exactly the sort of thing that our downstream users want to look at. And so happy days, I found it straight away. Happy accident. Again?
Terrorstämplade.
He has a little like a derisive laugh.
Så kallad antiterrorlagstiftning.
So this, yeah. This.
Så kallad antiterrorlagstiftning.
Does this actually do anything?
Så kallad antiterrorlagstiftning.
It's already at max. Right, so I mean, this is not only a false start, it's a false start with a phrase inserted. So this is harder to catch. Right, done. This one from earlier. Phoneme recognizer, got it.
6. Debatt.
And it kind of got this.
Och utvecklas. Tack fru talman och tack.
It missed out on, well, what sounds like eroticism. It missed out on that because those are very short. I think that's mentioned on a future slide. It's not perfect. There are a few mistakes here.
Herr talman, EU-samarbetet gör Sverige starkare och säkrare. Hot som klimatkrisen, pandemier, terrorism och organiserad brottslighet kan inte lösas av ett enskilt land. It did quite a good job of catching the pauses and hesitations.
Vi gör. Kan bara konstatera att ungefär 200 personer i veckan som nekas inträde i Sverige tack vare, och det upptäcks via de inre gränskontrollerna för att de inte har rätt att komma till Sverige. Kan också konstatera att Säpo gör bedömningen att terrorhotsnivån mot Sverige ligger kvar på på en 3, vilket är en ganska hög nivå, vilket också motiverar ökad säkerhet och även inre gränskontroll. Sen finns det
And with this, it picked out that there was a different pronunciation than standard.
På den andra sidan har israeliska ungdomars liv präglats av rädsla och oro för terrorattentat. I båda länderna ökar uppgivenheten och radikaliseringen.
I swear I picked this out before the current crisis. But yeah, so instead of any of the usual pronunciations of how she says "oh," and I've verified this. So other things that we're doing. So we're going to be going back to HMM-based forced alignment because it tends not to skip over as much. So there's a shorter stride. It's 10 milliseconds instead of 20. And with that, you get to catch these really short R's and L sounds. And it's dictionary based. We'll be generating the dictionary, but then, you know, it either aligns or it doesn't. So if something doesn't align, we need to go back and check it. And we're looking at making an acoustically validated pronunciation dictionary. For the vast majority of these speakers, they're public figures. We know who they are. We know where they grew up. We know where they were born. So we can give very good guesses as to what their dialect is going to be. And so to begin with, we're doing an intersection of dictionary-derived pronunciations and the phonemic transcriptions, which is great if it's a Stockholm speaker because pronunciation dictionaries tend to favor the Stockholm dialect. We're using rules to add various alternatives and context-based replacements. And in the end, we want to get dialogue-specific lexica to begin with, and then other things based on speaking rate and other factors that will be useful mostly for text-to-speech research. Hopefully I get to just pick this package up and go, here you go, let me know if there are any problems, but we'll see. And so based just on Wiktionary, rather than a much larger dictionary that was harder to work with, these are the top 10 validated pairs. So the written form taken from the intersection of the transcript and the ASR output, and then the pronunciation that occurred at the same time step. There was a question last time because the first word is pronounced at and not o, which surprised people. I've looked it up since. This is an error in Wiktionary. They've given an alternative pronunciation of which happens maybe 40 times in 6,000 hours, but happens quite a lot.